We're now ready to find compositions of inverses of functions. Now, you've probably heard the word decomposition. That's when things break apart. Composition is just when you use things and build things and put them together. A common composition of functions, if you think of your washer and dryer as functioning machines, the washer washes the clothes, the dryer dries the clothes. Most people use both the washer and the dryer. There's very few people that only want their clothes washed. They like to line dry them. Or a few people that only want their clothes dried if they like to hand wash them. Most people like both. So if you think of it that way, you start with your your dirty dry clothes. You put them in the washer and out come clean clothes, but they're wet, and that's no good. So you put them through another function, the dryer, and you end up with clean, dry clothes. So that's kind of what we're going to be doing here. We're going to be taking the outputs of one function, making them the inputs of another function to get a new output entirely. So a little bit of notation. Sometimes you'll be hearing these functions, composition of functions called FOG and GOF. F-O-G. It's not really an O. It's kind of like an open multiplication symbol. But this notation is the same thing as F of G of X. That's how it's read. And similarly, G of F of X can be rewritten G of F of X. So that's just a little bit of notation. It might not mean a whole lot to you just yet until we get through some examples. So first, we're going to be trying to find F of G of 5. Now, I like to automatically rewrite my composition notation like this. I think it's much easier. The first thing I need to do is figure out the inside when I have numbers here. 5 is a number, so I need to figure out what is G of 5. So I'm going to start with G of X, because it tells me use the G function. And I want to figure out what is G of 5, which means you take out the X and you replace it with a 5. I took out the X here and put in a 5, so I'm going to do the same thing on the right. Always take note to use parentheses, that way you don't mess up your signs. So G of 5 ends up being 5 cubed, which is 125, plus 1 is 126. So again, I'm going to take this output, because that is literally what G of 5 is, and I'm going to go back and replace it here. F of 126. So then off to the side, I'm going to calculate F of 126. So my F function here was 3x minus 6. That's what my F function was, F of x. But I want F of 126, which means I'm going to take out the x and replace it with 126. So it's just like another substitution. Using our calculator, 3 times 126 gives me 378 minus 6 is 372. Therefore, F of G of X is 372. Final answer. Let's try going in reverse. What happens if we do G of F of 5? G of F of 5. Well, again, starting on the inside tells me to grab my F function first. F function is 3x minus 6. Then it tells me to take out the x and put in a 5 everywhere I had an x. And solve. 3 times 5 is 15, take away 6 makes 9. So G of F of 5 is the same as G of 9, because F of 5 is 9. So next I need to do g of 9. So I'm going to grab my g function, which is x cubed plus 1. I'm going to take out this x, and I'm going to replace it with a 9. 9 cubed is 729 plus 1 makes 728. So g of f of x, g of f of 5, it's 728, final answer. Now we're going to take a look at what happens when we're not given functions in an equation form, but rather a list of points that are part of the functions. This is Mrs. Wigger's favorite part, so if you ever have any trouble, just be sure to check with her. She will really enjoy helping you with that. We are going to find f of g of x and g of f of x, but we can't do them at the same time, so we're just going to look at the first one. The first one is f of g of x. Notice if I look at the inside again, the inside is g of x. So that's what I want to start with. But in order to find g of x, I need to know what to put in there. Well, what do we put in here? We put in the x values. And I'm putting them into g, so I want to look at just the g function right now. I'm going to make a list of all the x's. See, x, y, x, y. Every point has an x value and a y value. So I'm going to say 4, 2, 9, 3. Now I'm going to compute g of 4, g of 2, g of 9, g of 3, but since it's not written in an expression, we just go to it. G of 4, when x is 4, y is 3. Next, when x is 2, y is negative 1. When x is 9, y is 4. When x is 3, y is 10. That's my next column. Next, we want to take f of g of x. Well, remember, this is what g of x equals. So we need to take f of all of these. We want these to be our x's now, looking at our f function. So I'm no longer looking over here at the g function anymore. Now we're ready to take them from the washer and put them in the dryer. So when x is 3, in other words, f of 3, f of negative 1, f of 4, f of 10. When f is 3, when x is 3, I get negative 2 spit out to me. When x is negative 1, I get negative 5. When x is 4, y is 7. And when x is 10, I get 8. These are the y's of my composition. So now if I want to state my answer, use that little squiggle bracket, and we're just pairing them up. X is 4, y is 2. At this point, we can kind of ignore these middle two columns of our chart. 4, negative 2. 2, negative 5. 9, 7. 3, 8. If it wants to know the domain, that's just going to be all the x values, which in our case would be, I like to put them in order, so 2, 3, 4, and 9. And the range would be negative 5, negative 2, 7, 8 from least to greatest. So that's how we find f of g of x. I really think putting it into a little table like this will help. Starting with what's on the inside, grabbing the x values from that same function, writing your answers here, and then composing them with f to get your answer. Let's also figure out g of f of x. We'll do that next. So we went the first direction. G of f of x is next. And if you recall, notation-wise, that just means f is the function on the inside. So if I want to compute this, I need to start with what's on the inside, f of x, which means I need to grab my x values. They need to come from my f function. So 3, -1, 4, 10. I'm just grabbing them right here from my f function. When I compute f of 3, f of -1, f of 4, f of 10, what answers do I get? Well, when x is 3, y is -2. When x is -1, y is -5. When x is 4, I get a 7. And when x is 10, I get an 8. So next I want to take g of f of x. I want to take g of all of these. In other words, I want to put each of these into the function g as the x value. And out come the y's. So when g is -2, what happens? There is no -2. So we just write undefined. When x is -5, oh no, undefined again. That's okay, that happens. How about 7? Oh, undefined. And finally, 8. There is no 8, undefined. When this happens, when all of them are undefined, the entire composition is undefined. If a couple of them work, then only those are included in your answer. For instance, if I had an answer for g of -2 and g of 7, those would be part of my answer, my ordered pairs, and the rest would not. And here, my domain, when this happens, is empty, and my range is also empty. There are no values in my domain or my range for the composition of G and F. All right, the last thing we're going to do today is the same thing. However, now we're going to actually have functions, not ordered pairs. So we still want to find f of g of x, and we also want to find g of f of x. When we do this, we're going to start with the f function. F of x is x squared plus 2. But we don't want f of x, we want f of g of x. So we're going to take our eraser and erase this, and we're going to put g of x. And I'm going to erase the x over here and replace it with g of x. So you start with your big function on the outside, f, and you change all the x's to the g of x. It goes right in, making a little substitution there. Next, I have to multiply this with either box or FOIL, and I get x squared minus 12x plus 36 plus 2. Simplifying further, I get x squared minus 12x plus 38. And that's my answer. X squared minus 12x plus 38. Let's go in reverse. Let's compose f and g in the reverse order. We're going to start this time with g of x on the outside. G of x is x minus 6. Notice how sprawled I'm writing? That's on purpose because now I'm going to take out the x and put f of x. I'm going to take out this x and replace it with f of x. So when I take it out by erasing it, I'm going to replace it with x squared plus 2. And we simplify. There's nothing to square. There's no exponent outside the parentheses, so we have x squared plus 2 minus 6. Like terms combine. X squared minus 4. But of course, we also need to list the domain and range for our newly composed functions, which is very simple to do with the assistance of graphing technology. So I'm going to minimize my screen and pull up Desmos. All right, when I type x squared minus 12x plus 38, I have my function here. I'll even take a little screen grab of it so that we can easily highlight it in OneNote. Alright, I snipped my first picture. Next, I'm going to snip my second picture, x squared minus 4. If I make this a little larger and snip this picture, I can also put this in my notes. Shrink it down just a little bit so that it fits nicely. All right, let's take a look at the domain and range of each of these. Remember, the domain is all of the possible x values. And this goes on forever in both directions. So there's clearly graph above me right here on the x-axis, but it goes on forever to the right, and it goes on forever to the left. So my domain would be all real numbers. Which we typically write in interval notation as negative infinity to positive infinity. Now let's take a look at the range. Looking at my range, I'm looking at where there is graph to the left and the right on my y-axis. No graph, no graph. In fact, let me get rid of my other highlighting for a moment so as to not confuse anything. Starting at the bottom, there's no graph until I get to about here, and then there's graph to the right. Do you see the quadratic is sitting to the right everywhere I go? This point right here is the point 2. So my range is when y is greater than or equal to 2, which looks like that. Let's find the domain and range of this function, our second one. Again, the range, or the domain rather, there's graph above me or below me right here, but it goes to the right forever and it goes to the left forever because this is a quadratic. So my domain is from negative infinity to positive infinity. Next, let's take a look at the range. My range is where on this y-axis there's graph. I'm looking left and right now. There's no graph to the left or the right until I get to here. And then there's graph on the left and on the right, actually, all the way up. So we say, well, what is this point right here? This is the point -4. So from -4 to infinity, we have our range.